I'm Dave Kassler, amateur radio call sign KE0OG, here with episode 109 of Ask Dave. Today, let's take a closer look at the QRP Labs QCX single band 5-watt CW only, meaning Morse only, QRP radio transceiver kit. Many things are revolutionary about this rig. This is a full-featured radio at a groundbreaking price of $49 US and $6 US shipping for a 5-watt radio. It's by far the lowest price, fully functioned QRP kit radio. At the same time, it contains many advanced approaches drawn from software-defined radios. Who can use this radio? Well, it's a CW-only radio, meaning Morse code. All hams, including technician, have CW privileges on 80, 40, 15, and 10 meters. Technicians, here's your chance to try HF. Given this is a single band radio and you choose which band at the time of ordering, I recommend starting with 40 meters. The 40 meter band is a haven for slower code, so don't be afraid to try. The QCX is a remarkably unique radio, and it first hit the market in August 2017, debuting at the Friedrichshafen Hamfest in Germany. Hans Summers, G0UPL from the UK, designed it. It's not a super heterodyne radio. It meets some of the definitions of a direct conversion receiver, but the QCX doesn't do it in the traditional way. Instead, the radio uses what's called a TAYLOE detector. Yes, T-A-Y-L-O-E. And the transmitter side uses a super efficient Class E amplifier. What's more, the radio has a built-in iambic memory keyer, has an A and B VFO, receiver incremental tuning, frequency memories, and even a built-in microswitch that you can use as a straight key. And after you build it, it contains built-in test equipment to aid in the final alignment. You order the radio from QRPlabs.com. Select the QCX radio. Note that right now they're running a bit behind because of the radio's popularity. My second one arrived today. It comes as a small packet from Tokyo. Let's open this one, serial number 1200, to show you what's inside. Okay, we get this envelope, which we'll open up. And here is the band kit. These are the parts that are specific for 40 meters. This is the rest of the kit right here, with a bunch of bags inside a bag. So we'll just open this up here and see what we've got. Bags, this looks like controls potentiometers, connectors, volume knobs, things like that. Here are a gazillion small parts, including the transistors. Here's more transistors here. It's interesting, they sure look a lot alike, don't they? That's a crystal. Okay, here is the board itself, which you can see if you look at your finger on this thing, that things are fairly densely packed. If you notice here, there are two surface mount devices already mounted on there. Those are the only surface mount devices, so you don't need to worry about having to mount any of those. We've got all of the ICs. Here is the chip version 100C. This is the microprocessor, and it has the programming in it already. And this right here is actually the little display device. So we're going to turn all of that into this. Everything is carefully packed and there are lots of components. You will have to get the manual from the QRP Labs website. It's worth it to have it printed in color. I printed mine double-sided and had it spiral bound at my local Office Depot. Make note of the version number and double-check the website to see if there have been any changes. In my case, the newer manual corrects a parts swap that makes the radio easier to align. From a kit point of view, it requires absolute attention and patience to build it correctly. The components are crammed onto the 3" by 4" circuit board. You'll need to be careful about letting solder cover more than one solder pad. Some sort of magnifying lens is pretty much mandatory because parts are small. You can use something like this, or this magnifying headset here, or this magnifying light. You will have to solder several integrated circuits. In one bit of relief, the two surface mount components come already soldered to the board. This isn't a panacea, however, for I found that a subatomic solder ball was shorting 2 pins of one of the surface mount devices. So even though these parts are already soldered on the board, do check them to make sure the connections remain clean. It took me a few days, a little at a time, to complete wiring the kit. I use a circuit board holder I got on Amazon. It's inexpensive and makes working on boards amazingly easier. I recommend you use something like this to keep the frustration down below the boiling point. All soldering is done on one side of the board. The instruction manual is a delight to use. For each step, it has a picture of the board with the spots for installation circled in red. Parts you have already installed up to that point are in gray, and as yet uninstalled parts are white. This makes it easier to put the parts in the right place. For whatever reason, winding and installing the toroid inductors is left for near last. Please follow the instructions exactly. The last toroid to wind and build is transformer T1, a critical part of the receiver. It is very easy to get this wrong. In my first kit, I had 2 colors of magnet wire for the toroids. I recommend you use one color for the primary winding and the large secondary winding S3. Then use the other color for S2 and S1. This separates the windings nicely and helps get the right wires in the right holes. T1 is critical, and all 4 windings have to be perfect. On 40 meters, the T1 toroid core is barely big enough for all the windings. This brings us to soldering those toroid leads. The instruction book says you can either scrape or sandpaper the enamel covering off at the connections, or you can hold a solder blob over the wire for about 10 seconds to burn off the enamel. This latter selection does work, though I would recommend holding that solder ball until you see the smoke rise to indicate the enamel has burned through, which for me was about 20 seconds. It is crucial that all connections be properly soldered, and the book suggests the use of an ohmmeter to check to help ensure good toroid connections. I point out that T1 may have the number of turns on S3 changed during the alignment, so you'd have to unsolder that. Once you have the kit together, the manual takes you through an alignment process. Every step of the alignment process has to do with the receiver side. transformer secondary 3 forms a tuned circuit along with a fixed capacitor and a variable capacitor, and this must be brought to resonance. I should like to talk about the halo detector. The very core building block of the radio is an SI5351A chip that is so tiny that even when I bring the camera as close to the circuit board as possible, it's still small. This chip uses a 27 megahertz crystal as a basis to digitally synthesize any frequency desired in 10 hertz steps. The output is 3 independently programmable square waves. Now, in this radio, the chip has 3 outputs at the same frequency. They're square waves and are thus called clocks rather than signals. The SI5351's first 2 clock outputs are at the VFO frequency, except clock 1 is delayed by 90 degrees from clock 0. 2 clocks 90 degrees out of phase are referred to as being in quadrature, because if you look at the 2 clocks as though they were digital numbers 0 and 1, they count 0, 1, 2, 3, and then repeat over and over. These clocks drive the other surface mount device, this one a bit bigger, where each puts out a signal sample with each sample 90 degrees behind the other. These are each integrated and then fed to amplifiers to produce audio signals that are in quadrature, meaning that on the second audio signal, every frequency is delayed by 90 degrees. So high frequencies get a little delay and lower frequencies get more delay. Circuitry reduces this to 2 quadrature signals, which is really all we need. If you subtract one of these from the other, you get one sideband out. If you add them, you get the other sideband out. The net of this is that one sideband is canceled and the receiver provides only upper sideband. This is a neat little trick, and you can see that this is an entirely different way of handling signals from the traditional superheterodyne method. The transmitter is simplicity itself. Clock 2, a square wave, turns the output finals, 3 transistors in parallel in class E, on and off at an RF rate. Note that the transistors are either off with 0 volts across the output or on with 0 volts across the source and drain, and in both extreme cases the transistors do not conduct. This creates very high efficiency. The output is an amplified square wave. Recall that a square wave consists of a fundamental frequency plus a mixture of odd harmonics that start with the third harmonic. So if the fundamental is set at 70-50 kilohertz and you filter out anything above that, you're left with a nice sine wave at 70-50 kilohertz, which is fed to the antenna. This approach results in a signal that meets all FCC spectral purity requirements. My watt meter shows it's very nearly 5 watts out. This contrasts with some easy-to-build QRP rigs today that only put out a watt or 2. 5 is nice. If you run into trouble building it, there is a very active QRP Labs group online at groups.io/g/QRP Labs. I went there when I ran into trouble. I posted a screenshot from my oscilloscope. I received several suggestions, and one proved to be the key, that there was a short between clock 0 and clock 1. I got out the microscope that Michael Lloyd sent me for doing surface mount device work, and sure enough, I found the short. I dislodged it easily. Immediately, the 2 clock outputs were in quadrature, and the radio started working well. I have had a QSO on the radio, even though I've only had it for a very short time, and can report from an operating point of view, it's a great radio. There's a 200 hertz CW filter centered around audio at 700 hertz, but it lets in just enough of the higher and lower tones so you don't miss them while tuning around. Let me go through some of the features of this radio. The first, of course, is the digital display. It tells you the frequency to 10 Hertz precision, and my experiments show it's remarkably accurate. It can show 2 different VFOs, or receiver incremental tuning, or signal strength, and with the addition of a single wire, the battery status. You use the display, the push buttons, and the rotary encoder to do all the setup, and there are lots of options. The rig even has a built-in Morse code decoder, although its accuracy is nothing to write home about. It only works on really strong, perfectly formed Morse. Interestingly, it will also decode your sending, so that's a way to check the quality of your code. You can use a straight key or set of paddles. The built-in keyer allows iambic A and B as well as ultimatic. By the way, I recommend iambic B is the easiest, although fanatics abound on both sides of the A versus B question. Now, I want to talk about a feature that is hardly ever mentioned in reviews. There is a micro switch right on the board that can act as a straight key. It's a little hard to send well-spaced CW using it, but it does work. I note here that new straight keys and paddles are expensive, ridiculously expensive. Even the lower cost ones cost more than this entire radio. There is only one inexpensive key available these days for retail sale, and it's this one, and frankly, it's not sturdy at all. Now, I purchased this old J38 at a Hamfest for $5, and frankly, that's about the right price. The J38 dates back to the early 1940s. It's a great key and will last nearly a lifetime. But what the amateur radio CW world lacks is a good, sturdy, inexpensive key, and there isn't one. So, Hans put this micro switch right on the radio circuit board to use as a key. It's a little awkward to use, so try moving your finger up and down the lever to see what works for you. I find I can send readable code at perhaps 10 words per minute using the micro switch. Is this switch a good place to learn to send Morse code? Opinions may vary, but between your ear and what the transceiver decodes on the display screen, you can get it right. And techs, I suggest this radio for you. You already have CW privileges on 80, 40, 15, and 10. I suggest you start with 40 meters. Put up a dipole or something else cheap. Call your friends on 2 meters to meet you on 7115 on 40 meters and teach each other Morse code. I'll make this prediction. The very best way to learn CW is to get on the air. Sure, keep that 2-meter link going so you can laugh at each other's sending, but keep at it. You and your group will get better and better, and with time, you'll feel empowered to have QSOs with those outside your group. By the way, the reason I have 2 is that I forgot I had ordered the first one. The delay was that long, but I have one that has all the controls built on the board, so I'll build this next one for off-board mounted controls. The QRP Labs backlog is quickly being reduced, so the time to get one is down to about a week or so once it ships. At US $55 each, including shipping, it's the bargain of the year. Thanks so much for watching. Please click like and subscribe. Until we next meet, 73. Next week, we'll look more at antenna modeling and what the various diagrams mean. Check out the previous and next videos in the Ask Dave series. And check out my support page.